Well, welcome back everyone. Today I'm going to do a super quick tutorial on how valves or tubes actually work. I'm just going to cover off on the four main ones, diode, triode, tetrode and pentode. But after looking at those, I'm hoping that gives you a bit of an understanding on how they actually work. And if you want to look at some of the other varieties that are available, hopefully you've got a bit of a base understanding of how they actually work now. So please like and subscribe if you like what you see, and I'll see you at the end of the video. Okay, so the first one we'll look at is a diode. So let's draw that up. If we draw the cathode at the bottom here, and let's apply a negative voltage to that cathode, what we'll find is the cathode's been treated in a way that it will emit electrons. So you'll get a cloud of electrons at the cathode. So now if we put another electrode in this valve and apply a positive voltage to it, the electrons will naturally be drawn to that positive plate. So you'll find that you get a flow of electrons from the cathode to the anode, and the electrons can't flow back the other way. So we've in fact got a diode function here. So a diode can be used for rectification, for generation of power supplies, and of course you'd remember from the tutorial on the Super Heterodyne Receiver, it's used as the detecting element as well. So now let's have a look at a triode valve. We'll just draw it up here now. We'll draw the cathode, and rather than a negative voltage, we'll actually set the cathode to the earth voltage at this time. And again, we'll put the anode in and set it to a positive voltage. And again, we're going to get a cloud of electrons forming at the cathode, but this time we're actually going to introduce a new element called the control grid, and we'll set it to a slightly negative value with respect to cathode. What we'll find is the more negative that is, the more it repels the electrons and stops them flowing through to the anode. And as you bring that control grid more positive, it stops repelling electrons so much and allows more current to flow through to the anode. So in effect, we can actually control the anode current by varying the control grid voltage. So when we look at the characteristics of a valve, we can actually find that there's a linear region that allows us to operate the triode as an amplifier. Now, with most things in life, there's no free lunch, and unfortunately the triode was the same. It had its issues. What they found was when it was used as an amplifier in a tuned circuit, it used to break into oscillation fairly easily if the amplification was too high. And this was found to be due to parasitic capacitance between the anode and the grid. Now, the anode is effectively the output of the amplifier and the grid's the input, so that feedback path allows oscillation to occur. So while we now had a great little amplifier, there were some restrictions on the level of gain that we could actually use. So let's take a look at the tetrode next. So let's draw up the tetrode. We'll start with the familiar triode. Cathode returned to our ground potential, positive on the anode, and our control grid will be slightly negative, thus controlling the amplification of the actual valve. So in the triode we learnt that millicapacitance causes an issue with oscillation. So what they did in the tetrode to fix this issue is introduce another grid called the screen grid. The screen grid was set to a voltage which is normally just slightly less positive than the anode. And effectively what actually happened was it isolated the control grid and the anode. So with the oscillation issues sorted out, we could use much higher levels of amplification using the tetrode. Now in the actual valve, what we find is as the electrons pass the control grid, they get accelerated by the screen grid, However, the screen grid is a fine mesh and the electrons tend to go straight through it to the anode, which is more positive and more attractive to them. So what was found was the Tetrode could be operated at much higher gain levels than the triode because of that isolation factor. Now again, no free lunch. The Tetrode actually had issues itself in that the electrons, when they strike the anode, occasionally there's going to be secondary emission, so electrode will bounce off effectively. Now in a triode that wasn't really a problem because the electrodes would be attracted back to the anode again and just recaptured. But in the Tetrode we've introduced a second element that's positive, and quite a few of the electrons were actually being captured by the screen grid. So again, another issue. However, the Tetrode did solve an issue of amplification, so valves could now be operated at higher gain levels than triodes. Okay, so let's take a look at the Pentode now. We'll see the familiar drawing from the other valves in that the cathode being returned to ground, an anode, and again it's set to a positive voltage, and our control grid just slightly negative to control the current through the device. Our screen grid, which is just less positive than the anode to accelerate those electrons towards the anode. And we're now going to introduce a new grid called the Suppressor Grid. And it's normally returned back to the cathode potential, so ground. Now we learnt in the Tetrode that we get secondary emission and sometimes that is captured by the screen grid. Well, in the Pentode we have the same sort of operation. However, when we get secondary emission, because we've now got the suppressor grid at ground potential, it tends to reflect or repel the electrons back up towards the anode where they get captured by the anode. So we don't get any capture and current through the screen grid. So this was a great advance, and now we had the advantage of the possible gain of a Tetrode without the negative issues associated with that secondary emission. So there we go, we've covered off on the four main valves you find. Certainly there are others with more elements in them, and they were designed mainly for mixing in radio circuits to reduce the number of valves and things like that. But there we go. I'll wrap this video up now. If you do like what you're seeing, then please do like the video. If you'd like to see more of what I'm doing, then please subscribe and hit the little chime so that you get notifications when I do something new. And also I should add, I've created a few little information sheets about these four valves, and they're available on the website, and there will be a link down below to get to them. Okay, cheers till next time.